All right, hello again, pre-calculus people. So we're going to do a quick review of transformations. This should be all reviews from Algebra 2, but we're going to talk about transformations just in general, the general form, for all different pair of functions, how to graph them, how to write the equations, how to recognize equations from graphs, all that good stuff like that. So remember, your general form is this. It's that A times f of b of x minus h plus k. I will say, depending on the textbook and for your teacher, they may use c and d for h and k, but it's the same value. So I tend to use h and k for these. So what do all these things do? All these things do, and again, all these things should be reviewed for you. So let's talk about a first. So if you see a number outside of the function, and I can just kind of make one up just at random. So let's say we have something that looks like f of x equals 3 times 2 parentheses x minus 1 squared minus 4, something like that. And again, I just made that up just to show you what all these things are coming from. So like in this case, my a would be 3. What is that doing to the graph? Well, a can do one of three things. It can be a vertical stretch. So if a is positive, if a is greater than 1, I should say, if a is greater than 1, then it's going to be a vertical stretch, which you can think of it as making it thinner or skinnier or steeper. A lot of different words you can use for that. If a is less than 1, then it's a vertical compression. And again, you can think of that as going wider or kind of flatter, depending on kind of how you look at that. But again, that is your actual a value. If a is negative, so in this case here, it doesn't matter what the number actually is, but if you see a negative sign out front, then it is a reflection across the x-axis. Okay? So that's your a value. How about your b value? Now, I will say, in full disclosure, we are not going to deal a whole lot with b values until we get into trig next semester and the sine and cosine functions. But it does kind of do a similar thing as the a, only it's going to be a horizontal change. Okay, so for the b values, now notice they're kind of backwards from what a did. So now it's a horizontal stretch when b is between 0 and 1. It's a fraction, like 1/2 or 2/3 or something. And it's a horizontal compression when b is greater than 1. Okay, so like 3 or 5 or whatever. So again, it's hard to kind of demonstrate what that looks like until you know what a sine and cosine function look like. So don't worry too much about those guys. Just kind of know what the properties are of those things. What we can definitely do now is if b is negative. So same deal. If a was negative, it reflected across the x-axis, so it was upside down. If b is negative, it's going to reflect across the y-axis. So basically, it's going to be backwards. Okay? So that's your a and b values. Those are multiplying factors, either in front of the whole function or in front of just the x value. Okay, the h and k are the easier ones. The h is going to shift right when h is greater than 0, or shift left when h is negative. Now keep in mind, this is going to look backwards. Okay, we'll talk about that when we get to some equations in just 1 second. That's where you got to remember the function itself was x minus h in kind of the format of that. So it's going to look backward, but it's going to be the same kind of values. And then k is just your shifting up and down. Okay, so if k is positive, it's going to go up. If k is negative, it's going to go down. And that's on the very outside of the function. The other thing I want to kind of show you, which I think helps some people, is notice the a and the k are both outside of the function, and both of those affect the function vertically, either shifting up and down, or a vertical stretch compress, or vertical reflection. Whereas the b and the h are inside of the function, and they both affect things horizontally. Okay, so again, shifting left and right, horizontal stretch compress, stuff like that. Okay? So let's get into a couple of examples on what you should be able to do. So the first thing, if I see a graph, if I see an equation, I should say, We can list the transformations. We can talk about what the parent function looks like, and then do a sketch of what the new function is going to look like. Okay. So in this case, again, we just look and see what we have. So here's my A value. Here is my H. Here's my K. So I know the A, again, it's less than 1, so that means it's a vertical stretch. I'm sorry, vertical compression. A lot of people call that a compression of a factor of 2, which means, again, this is going to get wider by a factor of 2, or yeah. How about the H value? Remember, we said the H is kind of backwards than what it looks like. In this case, the H is really negative, because really what we have here is minus a negative 1, which would be the plus 1. So that's going left 1. And then the minus 4 on the very outside, that's going down 4. Okay? How would I graph that? I'm not going to be super, picky on doing super accurate graphs, but we should be able to get a good sketch of this thing. So I kind of sketched the parent function of the cubic up here in the dotted red. So the first thing we want to do is we can shift that critical point of the origin. We can shift that left 1 and down 4. So if I go left 1 and down 4, I got a new origin right there. So that's going to be my new critical point. And then I know it's going to get wider by a factor of 2. So instead of going up 1 over 1, it's going to go over 1 and just up a half. So it's going to be kind of wider like this. Again, I'm not going to be super picky about that. The main thing I'm going to be looking for is the shape correct? Is it kind of based on the parent function that you know? And then is that critical point correct? Okay. The big part, though, again, is being able to identify what transformations are happening. Next example, so we got negative 2e to the x minus 1 plus 4. So again, we know it's an exponential function. You see the parent function over there to the right. Same deal. There's your A, there's your H, and there's your K. In this case, there's actually 4 things going on. So it's a reflection, because it's negative on the outside, reflect across the x-axis. So it's going to be upside down. It's also going to be a vertical stretch of 2. Again, my H in this case is positive, so it's going to go right 1, and it's going to go up 4. Okay? That's the big part of that. When you're graphing this, my only hint on graphing things with reflections is do reflections first. Okay? So again, I see my critical point is at 0, 1 for the parent function. If I reflect it, it's going to come down here to negative 1. And now I can go right 1, and I'm going to go up 4. So 1, 2, 3, 4. So my new critical point is going to be right there. Okay? Now, how do I actually graph it? Remember, this also has an asymptote. So I'm going to shift the asymptote also up 4. 1, 2, 3, 4. So my new asymptote is going to be up here. And again, I'm not overly worried about the vertical stretch of 2, but I know it's going to be a little bit steeper. So it's going to come up here and then come down through my critical point and then swooping down through there. Probably a little bit too steep because it's not really vertical, but close enough. Okay. And again, folks, I'm going to go through these kind of quickly just so the video doesn't run too long, but feel free to go back and look at the example again, pause it for a second, and kind of process. Okay. Let's do one more. I like doing a rational function or a square root function on this too. And I do want to throw a b value in this one. So notice this one, square root function. Here's our a. This one has a b, an h, and a k. Okay. So the A value, vertical stretch. The B is just -1, so that means it's reflecting across the y-axis, which means it's going to be backwards. The H is going to go left 5 and down 2. Okay? Now, the main thing about this one, again, is going to be reflection. So instead of going across to the right, it's going to go backwards to the left once we start drawing the graph in. And again, since my critical point is at 0, I don't need to worry about reflecting that because it's still going to be at 0 because there's no reflection that can be done with that. But I do need to shift it 5 left and down 2. So 1, 2, 3, 4, 5, and down 2. So there's my new critical point. And again, it's going to get steeper than the original, so it's going to go steeper and then going backwards, so something like that would be an okay graph for that. Okay, so y-axis reflection backwards, x-axis reflection upside down. The next thing you got to be able to do is look at a graph and identify, and then be able to write the equation that would be based on that graph would be, right? So in this case, and again, you have to recognize what pairing function it is. This is our V shape, so it's an absolute value. Transformations, it's upside down, so it's a reflection across the x-axis. And it's also, remember, my point of a V is usually at the origin, so it's gone right 2 and up 1. So I got everything I need for my equation, so I just do this. Remember, my parent function looks like y equals those 2 vertical lines. So this is going to be reflect across the x-axis. That's an A value, so a negative out front. If it's going right 2, remember that looks backwards. So it'd be x minus 2 inside the bars, and then plus 1. And that will be that function. Let's do one more of those for a rational function. Again, this is one with those 2 branches in the first and third quadrant. So this is rational. Y equals 1 over x is the parent function. What's going on here? Remember, normally my asymptotes are just on the x and y axis, right? So now we know that's been shifted left 3 and up 2. And that's all that's going on because normally, again, the graph is here and here. So it's in those same 2 quadrants as the origin shifted. So nothing else going on, no stretches going on and stuff like that. So that's going to be my equation. So y equals 1 over, again, my left and right go down where the x is. So it's going left 3, x plus 3, and then the up 2 on the outside like that. Okay? That's really the most of it. You have an assignment where you got I'm asking you to graph a couple of them just for practice. Look at some graphs and then write the equations. And then just take a verbal description and verbal descriptions like these, and then just write the equation. No, you don't need to have to graph those things. Okay? So we did go through the notes. If you need some more help with this, you can drop me an email, come to tutoring. And until next time, stay safe.